Hello everyone, this is Hossein from EJ Academy. In the previous video, we talked about how you can use factoring method to solve quadratic equations. We saw how you can use factoring method to solve a simplified version of quadratic expression where x squared multiplier a is equal to 1. In this video, we wanted to see how we can use factoring method to solve the general form of quadratic equation where a, the x squared multiplier, is not necessarily 1. As I mentioned in the previous video, the goal in factoring method is to convert the quadratic equation into a factored form where on the left hand side we have a multiplication of two factors, and if we convert the general form of quadratic equation into two factors, we would get two linear equation in terms of x, where x is the variable, and we have four unknowns. In this case, m1 and n1 are the unknowns that we need to find out for the first factor, and for the second factors we have two other unknowns, m2 and n2 in this case. If we go ahead and do the multiplication using distributive property, we would get m1x times m2x plus m1x times n2 plus n1 times m2x plus n1 times n2. If we further simplify this expression, we would get m1x times m2x is equal to m1 times m2 times x squared, plus the second term and the third term we have the common x multiplier, so we can combine them and write it as m1 n2 plus m2 n1 times x. And finally we have the last term n1 times n2 equals 0. If we compare this new expression with the original quadratic equation, we would get m1 times m2 is equal to a. The second term m1 times n2 plus m2 times n1 is equal to b, and finally the third term n1 times n2 is equal to c. So as I mentioned earlier, in the general form of quadratic equation, to be able to transform the original quadratic equation into a factored form, we need to find four unknowns, and we can use these three equations that we obtained here to find those four unknowns. Let's take a look at a couple of examples to see how we can use factoring method to solve quadratic equation. Our first example is 2x squared minus x minus 6 equals 0. Before using factoring to solve this equation, let's head over to Desmos to see how the parabola looks like. Expression that we have is y is equal to 2x squared minus x minus 6. So as you can see here, the parabola has two intersections with the horizontal axis. One is at x equals minus 1.5, and the other one is at x equals 2. So we expect to get two distinct roots if we solve this equation. Let's go back to our notes and use factoring to solve this equation. If you take a look at this equation, you see that x squared has a multiplier of 2, and we cannot simply get rid of it by dividing all the terms by 2. So this is a general form of a quadratic equation, and we need to general form of factoring to be able to solve this equation. As a reminder, I'm going to rewrite the factored form here. It was open parenthesis m1 times x plus n1, close parenthesis, open parenthesis, m2 times x plus n2, close parenthesis, equals 0. And the multiplication is obtained by applying the distributive property. So the answer would be m1 times m2 x squared plus open parenthesis m1 times n2 plus m2 times n1 times x plus n1 times n2 equals 0. If we compare this equation with the equation that we have in our example, we see that m1 times m2 has to be positive 2, and the multiplier of the second term m1 n2 plus m2 n1 has to be negative 1, and n1 times n2 has to be negative 6. So we have to find out what are the four unknowns m1 and m2 and also n1 and n2. In this case, it's easy to figure out what are m1 and m2. We know m1 times m2 is equal to positive 2. As a result, m1 has to be positive 2 and m2 has to be positive 1. You can also switch the values between m1 and m2. So let's go ahead and replace m1 and m2 into the factor form. If we do so, we would have 2x plus n1 close parenthesis open parenthesis x plus n2 close parenthesis equals 0. And if we use distributive property to do this multiplication, we can obtain the answer. Also, we can use this equation up here and replace m1 with 2 and m2 with 1 and write down the final answer. So the final answer would be 2x squared plus 2n2 plus n1 close parenthesis times x plus n1 times n2 equals 0. And again, n1 times n2 has to be negative 6 and 2n2 plus n1 has to be negative 1. So here we reduce the equation into a form that we only have two unknowns, n1 and n2. We need to try different pairs of numbers to see which of them match into the conditions that we have here. The conditions that we have is n1 times n2 has to be negative 6 and 2n2 plus n1 has to be negative 1. To stay organized, I'm going to use a table here. So the first column is n1, the second column is n2, the third column is n1 times n2, and the last column is 2n2 plus n1. So we need to try a pair of numbers that their multiplication is negative 6. Let's start with negative 1 and 6, and 2 times 6 plus negative 1 is equal to 11, which is not equal to negative 1, so that's not an answer. Let's try 3 and negative 2. Multiplication is negative 6. 2 times negative 2 plus 3 is equal to negative 1. We found the answer. So just to be complete, I'm gonna try one last case, which is negative 3 and 2. Multiplication is negative 6, and 2 times 2 plus negative 3. I know it is not going to be equal to negative 1. So the answer is 1, which is not equal to negative 1. So this is our answer. N1 is equal to 3 and N2 is equal to negative 2. So let's go ahead and replace these numbers into this factor form here. So if we do so, we would have open parenthesis 2x plus 3 close parenthesis open parenthesis x minus 2 close parenthesis equals 0. Because the right hand side is 0, the left hand side, each of these factors has to be 0. Let's set the first factor to 0. 2x plus 3 equals 0. And we're going to solve it for x. This is a linear equation. It's easy to solve. We subtract 3 from both sides. So on the left hand side we have 2x. On the right hand side we have negative 3. Let's divide both sides by 2. We would have x equals negative 3 over 2. This is one answer. The second answer comes from setting the second factor to 0. X minus 2 equals 0. Now we solve it for x. We add 2 to both sides of the equation. If we do so, we would have x equals 2. And this is our second answer. And these roots are exactly the same as we saw in the graph. Let's try one more example. Example number 2, the expression is 6x squared minus 7x minus 5 equals 0. Similar to the previous example, I'm going to graph this first. So let's head over to Desmos. Our expression is y is equal to 6x squared minus 7x minus 5. And you see, similar to the previous example, this parabola also have two distinct roots, and the roots are x equals negative 0.5 and x equal 1.667. Let's go back to our notes and use factoring to calculate these roots. Similar to the previous example, we cannot get rid of this x squared multiplier by just dividing all the terms by 6, because the other terms are not divisible by 6. So we're going to use a general form of the factoring method, and as a reminder, I'm going to rewrite that here. So the factored form is open parenthesis m1x plus n1 close parenthesis open parenthesis m2x plus n2 close parenthesis equals 0. And if we use distributive property to do the multiplication, we would get m1 m2 x squared plus open parenthesis m1 n2 plus m2 n1 close parenthesis times x plus n1 times n2 equals 0. Comparing this equation with the equation that we have in our example, we see that m1 times m2 has to be positive 6. The multiplier of the x in the second term has to be negative 7. And n1 times n2 has to be negative 5. Let's start by see what could be the values of m1 and m2. m1 times m2 has to be positive 6. There are a number of scenarios here. Because the multiplication is positive, either both of them are positive or both are negative. If both are positive, it could be 2 times 3 or 1 times 6. If both are negative, it could be negative 2 times negative 3 or negative 1 times negative 6. Let's try these scenarios here where m1 is 2 and m2 is 3. If we replace 2 and 3 into the factored form right here, we would get open parenthesis 2x plus n1 close parenthesis open parenthesis 3x plus n2 close parenthesis equals 0. And if we use distributive property to do the multiplication, we would get 6x squared plus open parenthesis 2n2 plus 3n1 close parenthesis times x plus n1 times n2 equals 0. And we know that n1 times n2 has to be negative 5, and 2n2 plus 3n1 has to be negative 7. So we need to try different pairs of numbers that their multiplication n1 times n2 is negative 5, and also satisfy this equation 2n2 plus 3n1 equals negative 7. Let's draw a table to be organized. So in the first column we have n1, the second column is for n2, third column is for their multiplication, n1 times n2, and the last column we have 2n2 plus 3n1. So we need to find a pair of numbers that their multiplication is -5. Let's just start with -1 and 5. 2 times 5 plus 3 times -1 is equal to 7, which is not equal to -7. So that's not an answer that we're looking for. Next one, 5 and -1, their multiplication is -5. 2 times -1 plus 3 times 5 is equal to 13, not equal to -7. Let's try 1 and -5. Multiplication is -5. 2 times -5 plus 3 times 1 is equal to -7. And this is the answer that we're looking for. Just to be complete, I'm going to try one more pair that is left here. -5 and 1. Multiplication is -5, and 2 times 1 plus 3 times -5 is equal to -13, not equal to -7. So what we found here is that n1 has to be 1 and n2 has to be -5. So let's go ahead and replace these numbers into the factored form up here. So we have 2x plus 1, close parenthesis, open parenthesis, 3x minus 5, close parenthesis, equals 0. Because the right hand side is equal to 0, each of these factors has to be 0. If we set the first one to 0, we would have 2x plus 1 equals 0. And we solve it for x. Subtract 1 from both sides. And I have 2x equals -1. Going to divide both sides by 2. I would have x equals -1/2. This is one answer. And to get the other answer, we need to set the other factor to 0. So 3x minus 5 equals 0. We solve it for x. We add 5 to both sides. We have 3x on the left side. On the right side, we have 5. We divide both sides by 3. If we do so, we have x equals 5 over 3, which is equal to 1.6 repeating. And this is our second answer. So these answers are exactly the same as we saw on the graph. If you remember, the pair of M1 and M2 had 4 different possibilities, and we only tried one of them, which was 2 and 3. Let's go back to the other pairs that we wrote for M1 and M2. Was up here, right here. These are the 4 pairs that we consider as being possible for M1 and M2, and we only tried 2 and 3, and there are 3 more left. We were lucky that the first one worked and we got the answer. I'm going to go ahead and try the second one, 1 and 6 here. So assuming M1 is equal to 1 and M2 is equal to 6, M1 times M2 is equal to 1 times 6 equals 6. So if you remember, the factored form was m1 times x plus n2, close parenthesis, open parenthesis, m2 times x plus n2, close parenthesis, equals 0. So I'm going to replace m1 and m2 with 1 and 6. I would have x plus n2, close parenthesis, open parenthesis, 6x plus n2, close parenthesis, equals 0. If I apply distributive property, this multiplication would be 6x squared plus, open parenthesis, n2 plus 6n1, close parenthesis, times x plus n1 n2 equals 0. By comparing this equation with the equation that we have in our example, we see that n1 times n2 has to be negative 5, and n2 plus 6n1 has to be negative 7. So let's draw our table here and try different pairs of n1 and n2. The first column is for n1, the second column for n2, third column is for n1 times n2, and the last column is for n2 plus 6n1. So we're looking for a pair of numbers that their multiplication is negative 5. Let's try negative 1 and 5. So 5 plus 6 times negative 1 is equal to negative 1. This is not equal to negative 7. So that's not an answer. So we tried all the possible pairs for n1 and n2, and none of them gave us an acceptable answer. We can conclude that the scenario in which m1 is equal to 1 and m2 is equal to 6 is not an acceptable scenario. So we reject that. So if I scroll up to the beginning of our example, we see that there are two more scenarios left. One is negative 2 and negative 3, and the other one is negative 1 and negative 6 for m1 and m2. I leave these two scenarios for you to try and see if these two scenarios would give you an acceptable answer. If you had any difficulties trying these two remaining scenarios, let me know in the comment section below, and hopefully I can help you with that. Let's recap what we covered in this video. Factoring is a method that can be used to solve a quadratic equation, and in this video specifically we use factoring to solve general form of quadratic equations where x squared multiplier is not necessarily equal to 1. It could be any number, and we solve some examples and we use factoring method to solve a quadratic equation and find the roots of the equation. That was it for this video. Till next video, cheers.